Hello everybody, this is the self-driving car submitted as part of the CMPE 243 course at San Jose State University. We are team AutoNav. As you can see, this is our Android application through which we are going to control our car. It has a map fragment through which we can provide directions for the car to navigate. It has a start and stop button through which we can start the motion of the car, and it has a Bluetooth on and off button through which we can control the Bluetooth module on the car, and it has a kill switch mechanism for the safety of the car. This is the car, and as you can see, this is the LCD screen. The LCD screen is used to provide some amount of data. So this is the home screen. The LCD is used to display data from different controllers present on the car. We are now looking at the motor controller. So the motor controller shows a graphical representation of the 5 different switches. So each of the switch corresponds to the directional data that is received from the master controller that corresponds to the motion of the car in the real environment. We are next looking at the sensors, and what the sensors do is they look for obstacles in the proximity of the car. So if the bar is red, it would imply that there's an obstacle corresponding to that sensor, and if the bar is green, it would imply that there is no obstacle and the car could move forward in that direction. We are next looking at the debug screen. So what the debug screen does is it shows it's used to debug it was used to debug the car, and it essentially shows a lot of data that is necessary for the debugging, such as coordinates, the next waypoint, the directional data, the speed of the car. And we are next looking at the IMU screen, which shows the heading, the bearing, and the directional data necessary for the car to move forward. Okay, so let's actually issue a source and destination coordinates for the car using our Android app so that it can move ahead. We are now going to set a source. We are right next to the student union, so the green marker indicates our source, and we are going to set the SJSU event center as our destination, and we do that. And once we zoom in, we can take a look at all the intermediate blue markers that represent our intermediate points. Now that we have our intermediate points, I'm going to start the car, and once I press a button, it sends the route from the phone to the car. As you can see, the car is moving pretty smoothly. That is because of the wheel encoder, which ensures that the car moves at a constant speed. It is now moving because of the coordinates issued from the Android app, and the car keeps moving towards the destination. And you can observe that the car might go near an obstacle such as this tree, and once it goes near the tree, the ping sensor senses that there's an obstacle to its right, and it moves the car away from it. And you can observe that all of these controllers work together seamlessly to ensure that the car avoids the obstacle and moves towards the destination. And now we are getting very close towards the destination, which is why the car has stopped. And as you can observe, we throw up a checkered flag on the screen to indicate that we reached our destination. We at Team AutoNav would like to thank Professor Preet for providing us an opportunity to work on such a complex project. We thought that the knowledge that we obtained from working on such a complex project was really invaluable, and we believe that this is going to help us solve a lot of complex real world problems. We believe that if worked hard, any problem is solvable, and this is what Professor Preet and the course has taught us. Team AutoNav is comprised of the following members, and thank you for watching this video.